demand for cooling in data centers, Bitcoin mines, and AI servers. In this digital age, data is everything. From streaming our favorite shows to powering artificial intelligence, massive amounts of information are being processed every second. But behind the scenes, there's a hidden challenge: cooling these massive heat-producing technologies. Take Bitcoin mining, for example. These machines work non-stop, solving complex equations to verify transactions. This process generates intense heat, and without proper cooling, hardware performance suffers, or worse, systems shut down entirely. Then there's AI servers. Training artificial intelligence models demands immense computing power. The more advanced the AI, the hotter these machines get. Keeping them cool isn't just about efficiency, it's about preventing costly downtime. So, how do we cool these high-tech powerhouses? Traditional air cooling is still common, but modern facilities are turning to liquid cooling, immersion cooling, and even waste heat recovery systems to improve efficiency. With global temperatures rising and energy costs surging, the industry is under pressure to develop greener, more efficient cooling solutions. The future of digital infrastructure depends on it. As technology evolves, so does the need for smarter cooling. The question is, how will we keep up, and who will work on it?
Well, hello, HVACR friends and families. It's so grateful to be able to have the time to hang out with you again here on Did You Know, the ESCO HVAC show. We've actually been on the road quite a bit over the last few months, and part of what we're going to do today is a little bit different. It's not necessarily a training class like we typically do. We're actually going to spend some time going through a behind-the-scenes video that we did at Johnson Controls at their Advanced Engineering Center over in Pennsylvania at JADEC. And really what we're looking for is, what resources do you need from us? What can we do to provide you with the tools to be successful, whether you're in the classroom, whether you're at work, whether you're the contractor, that technician, and the student. So we're going to be doing a variety of road shows going forward, but we need to know what is most important to you. As we have this changing industry, we have the opportunity to go to manufacturers, to actually do hands-on installations, to show you these products and technologies that we keep talking about. And what we really need is your feedback. Where do you want this show to go as we continue moving forward? We continue doing classes, but we have the opportunity to do some of these other amazing opportunities. So the live show, as well, the podcast, is now being represented by a public relations and marketing firm called Godfrey. And so they've been working with us to be able to get closer to the manufacturers, to be able to bring more behind the scenes information to the industry. And it's absolutely amazing. So we just came back from Skills USA last week. We went to Daikin a few weeks, probably a month or so before that. We've been at a variety of different trade shows. The one that we're going to review today is our first debut. This is a big one. This is like a 1 hour, almost like a behind the scenes documentary of what it's like inside of this Advanced Research and Development Center. So the reason we want to talk about these chillers in particular, remember, this is the largest chiller research and development and testing facility in the world. We've been invited by many of these manufacturers to go visit, to show what's behind the scenes, and to bring this information to you. Here in just a few weeks, we're actually going to get a behind the scenes tour over at Hudson Technologies, where we're going to go through like the life of a recovery cylinder in recovered refrigerants. What happens with that? What does it look like when it goes to the reclamation center? How do they do that? How do they separate things? How do they repackage them? And we want to make sure that you have the content you need. And like always, let us know where you're joining in from. We love knowing how large this community is growing. We want to get your feedback. I'm gonna throw in a feedback form as well. I had one put together previously on things that you can do to guide this show. It's to the point where we've even had discussions on like, what is the next studio going to look like? Do we need to be able to bring in some more pieces of equipment, do hands-on technologies, like hands-on troubleshooting, hands-on installations? We were even invited about 4 weeks ago to do an in-field installation with Johnson Controls, Copeland, Field Piece, and we're blessed to be able to do this. And you know what? I'm even going to throw this overlay on top. So glad to have you all here, right? Yeah, absolutely. Happy 4th of July to everyone coming up. It's a really, really cool opportunity in our industry to learn what's happening. So yeah, Katie, we just got to hang out with Katie at Skills USA. David Harold joined us in Cincinnati, ran into David there as well. Okay, so I'm going to need your input on this, right? So this is, you've probably seen some of these behind the scenes videos that we've been shooting here recently. This one's a big one. And so what we're going to do is we're going to utilize this to encourage other manufacturers to invite us to their factories, invite us into their distributorships, to show you anything within the industry that you want to see, to bring these technologies right in front of you. Like, how do they even manufacture some of this stuff, right? That's really what we're going to start spending more time doing. Okay, so here we go. So we're going to do this. Any of you from my generation, us Xers, remember Mystery Science Theater, right? Where we actually got to watch and do commentary on a show. That's what this one's going to be. So I am going to play it. It's in segments. We actually did it kind of like in chapters. And we're going to go through, what does this facility look like? What does it do? And show the importance of how they actually create and test. And it is just a phenomenal facility. And I'm going to be in the background. I'm going to be popping in and out, doing some commentary. And I want you to tell me what you think about it. Is this something that you want more of? Because this is the first one. This is the biggie that we take to the industry and go, okay, here is one facility in our entire industry. And here is everything you could possibly want to know about that. And if it's what you like, then we'll bring you some more. Okay? All right. So here we go. Everybody ready? Okay. In 3, 2, 1. Hey everyone, welcome back. Today you're in for a special treat. We're taking you on an exclusive behind-the-scenes tour of one of the most cutting-edge facilities in the HVACR industry, the Johnson Controls Advanced Development Engineering Center in New Freedom, Pennsylvania. This is where innovation happens, where engineers, designers, and technicians come together to develop the next generation of HVAC technology. From state-of-the-art testing labs to advanced system simulations, we're about to see it all. So strap in, get ready, and let's go inside to see how Johnson Controls is shaping the future of comfort, efficiency, and performance for the HVAC industry. The Johnson Controls Advanced Development Engineering Center, otherwise known as JADEC, is the largest and most advanced test lab of its kind in the world, spanning more than 7 acres and housing more than 20 labs, designed to simulate diverse building loads, applications, and climates. The JADEC facility designs and tests some of the most important equipment enabling the exponential growth of AI, like energy-efficient chillers, air handling units, and heat pumps. Well, thank you all for joining us. We're spending some time with Chris Carter, Director of Operations at JADEC. How are you?
I'm doing great, thank you.
You know, we're here to just take a view of this state-of-the-art research and development facility that we've heard so much about, because it plays a lot of important roles within our industry when we look at the changes and innovations that's happening, especially in things like data centers. You know, when we look at how our industry is moving into new roles, there are a lot of things that need to be tested and evaluated to understand, like, how does a piece of equipment work in an environment that we've never even encountered before? And so I know that is part of the roles that happen here. Tell us a little bit about the facility and how this testing and design and engineering plays a big factor within all of manufacturing at Johnson Controls.
Yeah, sure. So first of all, the JADEC facilities was specifically designed to support testing and validation in real-world applications.
Sure.
So we can cover extremely cold, extremely hot conditions to ensure operations based on any location in the world.
Right, not just the perfect lab setting, but
Absolutely.
once it gets out in the world and it's going to be in different locations around the world.
Right. So we talk
Yeah.
about our data center customers and various customers around
Right.
the world. They have specific criteria that they want to be met. We have the
Yeah.
ability to meet those objectives here, provide that to them, show them the operations and capabilities that we have here to be able to support their needs.
What would you say sets Johnson Controls, and particularly the JADEC facility, separate from any other manufacturer?
I would say it's the fact that we design and manufacture all of our subcomponents for our chillers.
Oh, yeah.
So the testing and validation that we do here for our subcomponent work in this facility, I would say is what sets us apart from others. Examples of some of this testing that takes place here is our heat transfer test lab, our gas block compressor testing facility, our variable speed drive dynamometer testing area.
Right.
These are just some examples, but I would definitely say this is something that sets us apart from others.
You know, we hear a lot about the equipment that's being manufactured by Johnson Controls, and how so much of it is truly manufactured by Johnson Controls, designed and engineered in-house. And then when you bring it into these facilities, like we're testing in conditions I'm hearing down to like minus 20
Yes.
and up to what, 131 degrees Fahrenheit, something
Yes,
like that?
that's correct.
Right, so we can actually put those pieces of equipment in those environments and see how they function.
Yeah, absolutely. Another great feature here is because of the features of our facility, we can place a chiller on a test facility at certain conditions for extended periods of time to ensure the reliability of it before it gets to the
longevity.
customer.
Sure.
So these are the advantages we have with our test facility.
You know, the thing that I was most impressed with when I walked into this facility is the variety of employees that you have here. You know, when you think of a state-of-the-art facility, you're thinking, oh, I'm probably just going to encounter a bunch of engineers, and that's all that we're going to see. But that's not the case. And I love to point out to the industry all the different jobs and opportunities within HVAC. You know, you and I have seen many different aspects of our industry, and there's so many roles and responsibilities and opportunities. You know, what does it take to be able to work in a facility like this?
Yeah, so I would say we have very unique positions that require different skill sets. We have dedicated recruiters, scouting teams that go out and look at the local industry to support recruiting top talent. I'd say that most of our operators that work here have manufacturing backgrounds that we train and develop. Some of that training that we provide includes obviously environmental health and safety training, chiller and facility operations, refrigerant cycle, data acquisition, software applications as it relates to the projects that we need to test. But also, we have a very diverse lab team on the engineering side that supports the execution of this facility. That includes environmental health and safety. We have HVACR, we have electrical, mechanical, data acquisition, software engineering backgrounds that all help support the execution of what we need to get done here.
Wow. You know, this is a state-of-the-art facility, and when it was developed, you know, I would look at a facility like this and go, boy, that's going to be a wonderful manufacturing facility.
Yeah.
It's not a manufacturing facility at all.
Not at all. Not at all. We the testing that we perform here, you know, we're testing to prove out concepts. We're testing for failure. We're testing to ensure that it's ready to release to manufacturing. So that's what makes us unique. That's what makes it so much fun on a daily basis, because we're constantly seeing something new. We're constantly implementing something new. So it's very fun to work on these types of projects.
I think Rob Tanner coined a phrase for this, that it's the beauty before the build.
Yep.
Right? You take something that is already potentially a done product, but then maybe you have a customer that says, boy, if you could do that, could you do this? And this is the kind of facility where you would take that concept and go, we're actually going to give that a try and see if we can actually do that. That might make changes into the next evolution of equipment.
Absolutely, and we have a lot of customers that come on site with different requests, different things that they want to see.
Customizations.
And and our goal and what we strive to do is to be able to meet whatever customer commitments or demands that they have. So we're constantly pushing the envelope, doing things that we have done before, but also reaching to learn and do other things that we have not done yet.
You know, we see a lot of new refrigerants like HFOs and HFC, HFO blends coming to the industry. And I imagine this is the type of facility where you bring those in and you do all the tests before the products are even released into manufacturing. So you probably get to see a lot of things that are changing in the industry before they've actually happened.
Absolutely, 100%. We have over 12 different types of refrigerants that we keep on hand. We've done a big transition to low GWP refrigerants.
Yeah.
So that's taking the place of older refrigerants, but we've done a lot of baseline testing with the older refrigerants, the newer refrigerants, to make sure that we're truly validating performance before we release these products to manufacturing.
You also mentioned that not just in-house testing and training, you actually do like on-site delivery of systems to do like longevity testing of some of these products as well.
Yes, absolutely.
Okay. So when we look at technology transitions, like we're going through a lot of technology transitions, refrigerant transitions, I think it's very important for us to see this side of manufacturing, really. So it's entire evolution of products. You know, when we go through these changes, we have to make sure that they're actually going to function when they get to market.
100%.
And so you have this beautiful facility that has a phenomenal amount of opportunities for test, design, and re-engineering. And I see that as crucial for a manufacturer going forward to be able to have this type of a facility that can prove the products in real-world applications.
Yep. 100% agree.
Okay, we really look forward to seeing all of these, which we're going to be going through the facility, getting a behind-the-scenes view of what we're going to have here going on at JADEC. So we encourage you to hang out with us. We're going to go through different stages and show you multiple aspects of the JADEC facility here in Pennsylvania.
Okay, so that's just the intro side of things, right? Just to kind of get you prepped for what we're going to do. We're going to go through a variety of different stations along the way. We're going to look at chiller side. So basically, we're going to be looking at the water side, the air side, technical training. We're going to go through a variety of different components of this. And one of the reasons that this is so important right now in our industry is, if you don't know, we're going through a significant transition in the way we use chillers in our industry. Like in the past, we've predominantly used chillers for comfort cooling, right? Using, air-to-air systems, water-to-air systems. And what we're seeing now is, because of the demand for data centers and the demand for HVAC technicians for cooling data centers, we're actually moving our chiller product development into these water-to-water systems for cooling these massive computers in AI servers and data systems. So it's really cool to see this transition. That's why we wanted to get a behind-the-scenes view of, what's happening back there. All right. I haven't seen any comments yet. Please, like I said, let me know, because I didn't know if this is something you'd all be interested or not, or if it's something I do standalone. I just wanted to get your feel of, these type of videos and content, if it'll be worthwhile, going down this route. It's not going to be all the time, but I'd like to get at least once a month, do this type of a video or behind the scenes shoot, or even broadcast live from the facilities. As long as it's something you want. Remember, this is for you. So we want you to direct where this show is going. All right, I'm going to move into the next one. I'll see you in a minute.
We're joined today by Roger Howard, acoustic engineer here at the JADEC facility. Roger, can you tell us what JADEC stands for?
JADEC stands for the Johnson Controls Advanced Development and Engineering Center.
Okay, so it's like the heart of everything new coming to the Johnson Controls products here on the air handling side.
Yes, that's correct.
Okay, so we're actually going to be witnessing a little bit of research and testing here in some of our applications a little bit later. What is the principal responsibility here at this facility with new equipment?
Primarily, we do research and development here.
Right.
We can do some testing of customer products, but any new product that we want to bring to the market, we primarily test that here first for things like sound, vibration, air performance, thermal performance. all of the parameters that we would report to our customers.
And this is a pretty new facility, am I correct?
Yes, this facility opened in 2017, so it's about 8 years old.
Excellent. So we're going to see a variety of new products. I know we're doing a lot of development for things like data centers, which is a huge emerging market. We've had a lot of conversations with our educators on programs to prepare technicians for those types of jobs in the industry. So we'll actually get to see some of that today.
Yes.
All right. Well, fantastic. Well, thanks for joining us. We hope that you enjoy this program, and let us know in the show notes and in the comments if you see some things that you're really interested in, you want to learn more. Let us know. We'll get you connected with more Johnson Control resources, and I'm really excited for today. All right, Roger. So now we're in the test lab area, which is kind of like stage 1 in this entire tour, kind of. Right. So what are we actually doing in this lab?
So in this lab, this is our air handling unit sound and performance test lab.
Okay.
So originally we were set up primarily to do sound and performance testing on fans and air handling units.
Yeah, sure.
We've since expanded that to do thermal testing for our data center units as well. So right now we're in the control room of the lab. We've got 3 data acquisition systems set up here, or data acquisition stations. We also call them DACs. This one, the first one here that is our data acquisition system for airflow, static pressure, fan power, and all of the air parameters such as air density, barometric pressure, humidity. All of these things affect sound. So we measure all of that with this station here. This second station is our newest station. This is our thermal DAC. We collect all of the thermal performance data for our data center units.
You betcha.
On this system. And then in the corner here, we have our original DAC, which is our acoustics DAC. This is where we collect the sound data from our reverb room and all of the testing that we do for the acoustic properties of our equipment.
Yeah, one of the things you were mentioning, what I thought was very intriguing, when we're looking at a generation of equipment, we actually have test standards on the decibel ratings that have a maximum range that they can be within a generation of equipment.
That's correct.
How does that function?
So the testing that we do for our air handling units in this lab is in accordance with AHRI standard 260.
Yes.
And so AHRI standard 260 requires a very broad sound map for testing, as well as a lot of data points. Fan manufacturers typically test to AMCA standards, and so what they would typically do with a fan would be to measure one speed line and 7 or 8 distinct performance points along that speed line, and then they would extrapolate that over the full operating range of the fan.
Oh, okay.
What we do here to test in accordance with AHRI 260 is for every fan that we test it at its lowest operating point and its highest operating point, but lowest speed and highest speed.
Sure.
We take 5 to 6 data points on each of those speed lines and 4 to 5 speed lines for each fan.
Okay.
And the reason that we do that is because we're not allowed to extrapolate data for the fan performance, fan sound performance. We can interpolate, but we cannot interpolate more than 5 decibels.
Okay.
So any of those 2 points that we test, and we typically take between 30 and 40 points of test data for each fan, cannot be more than 5 decibels different.
Wow.
If they are, we have to pick another speed line or another data point, performance point in between to meet that 5 decibel limit.
Well, that's pretty tight tolerances.
It is. And then that's just for one fan. For the entire family of fans that we offer in our product, we would test the smallest fan that we want to offer, the largest fan that we want to offer, and then approximately every other or every third fan in between in order to also meet that 5 decibel
standard
limit between fan sizes.
Wow, very intriguing. Okay, pretty critical. We don't think about like the sound of a fan. You know, there were days where the sound of a fan was just, you know, once it's changing fan speed, you'll notice it, but now you're actually engineering the equipment to stay within a very specific range of the sound of those fans.
Yeah, it's
intriguing.
In the last 20 to 30 years, acoustics and sound have really become an integral part of indoor environmental quality.
Yeah, especially as we start building our environments closer and closer to each other, we start thinking about, what is that sound quality? How does it impact our general, audio comfort, right? When we start talking about conditioning air, it's more than just conditioning a space. It's also making that a comfortable space as well, both physically as well as audibly now, and visually on some of them. See a lot of really nice looking products too.
Oh yeah, absolutely.
Excellent. All right, Roger. So we just came from our control center, right?
Yes.
Over here where we're grabbing all of our data. Now let's talk about where we're gathering that data from.
We're gathering that data from these two large air handling units that you see next to us.
Sure.
This smaller one is a 30,000 CFM air handling unit. The larger one behind me is 100,000 CFM.
Wow. Right.
So these are not only air handling units, they're very highly instrumented test instruments.
So these are all your baseline units that you're going to be measuring against equipment you'll have in the other facility.
No, these are actually our test equipment. They're our instrumentation. Sure. So we use these code testers to measure and control airflow and static pressure of the equipment that we are testing.
Oh, wow, okay. All right, so we've implemented all of the testing equipment into the actual air handler assembly itself.
That's correct.
Oh, very cool. And when we think about this one as a large unit, that's nothing compared to this thing.
Yes.
Right, so this is our, tell me again?
It's 100,000
CFM?
CFM, yes.
Okay.
So this lab is capable of measuring airflow and performance up to 100,000 CFM, whether that's a fan or an air handling unit or a data center unit, what have you. So it's one of the larger air handling unit acoustics test labs in North America.
Wow. Can we take a look inside?
Sure.
All right, let's do it.
So this area is the discharge plenum of the code tester.
Okay.
You can see we've got a pressure manifold around the wall. We use that to measure the external static pressure of the fan or the equipment that we're testing at the time. You can see we do have one of our data center units set up here for
this wall here?
future testing.
Exactly.
Yes.
Okay.
So this, I believe, is a 60,000 CFM data center unit.
Right.
I'm not sure exactly what the capacity is, but we can, like I said, test up to 100,000 CFM with this piece of equipment. Behind me, you'll see several layers of perforated sheet metal. Those are settling screens. And
for the airflow.
Their purpose is to make the airflow as uniform as possible so we can get accurate static pressure measurements.
Absolutely. In any ductwork scenario, we know that an open plenum is going to have a variance of air distribution and air disturbance, based on the construction of it. So you're softening and you're dampering that entire airflow to get consistent measuring through the entire chamber.
Correct.
Wow. Okay. Very interesting. Cool. Thank you.
Okay, how we doing? Everybody hanging in? You enjoying it? You all right? Okay. I know it's a little different than we normally do. That's why I was trying to introduce it to see if it's something that you would enjoy or not. So I'm going to go ahead and move into another stage. And if it's not meeting your expectations, let me know. We'll bounce back and we'll grab another topic. But for me, it's fascinating to be able to see what actually happens behind the scenes.
So that was the discharge of the unit.
Yes.
This next section is where we do the critical airflow measurement for the system.
Okay. Oh, some Venturis. All right.
Yes. These are very precisely ground and measured Venturi cones. We know the exact outlet area of each of these cones, and you can see we also have a pressure manifold around this wall. So by measuring the differential pressure across the wall and knowing how many of these cones we have open and their area, we can get a very accurate measurement of the airflow through this unit. And the reason that we use these units to control airflow and static pressure is that the equipment that we're testing, there's very little air pressure drop in our lab. You think about an air handling unit in a
real
building,
world, yeah,
it's got
absolutely.
ductwork, it's got other equipment that's generating static pressure.
Building pressures, every variance
Exactly.
that you can think of. Yeah.
We don't have that in the lab, so we use this unit to add or subtract static pressure depending on the data point we want to take.
Absolutely. So we're not just doing all the testing in a controlled lab environment. We're actually modifying our environment to be able to look at what real world application pressures would look like.
Exactly.
Sure, makes a lot of sense. Very intriguing.
So far we've seen the discharge plenum, the area where we measure the airflow of the system as well as the static pressure, and now we'll see the heart of the system, the control fan.
Oh, cool.
And this is what we use to generate the airflow and the static pressure of the unit.
Massive fan, I'm imagining.
It is. It's a
Wow, look at that.
It's a 60-inch plenum fan with a 150 horsepower motor.
That's incredible.
And it's got what we call an econo disc on it. This is basically a damper that can close off the inlet, and that's what we use to control the static pressure.
Yeah, you can modify the
system.
incoming pressure. Yeah.
Yes,
sure.
exactly. And then behind you, you can see we've got a bank of sound attenuators. As you can imagine, a 60-inch fan with a 150 horsepower motor generates a lot of noise on its own.
Especially no ductwork.
Right, exactly. So we want to deaden that noise so it doesn't contaminate our test data.
Oh, sure, absolutely.
So we've got a bank of these sound attenuators on either side of the fan.
To control that incoming, the return sound noise. Yeah.
Exactly, yes.
Wow.
And then this entire, if we step outside again, I can show you that this unit is currently configured to do discharge sound or airflow testing. If we want to do inlet airflow sound or testing, this fan actually has to be pointing in the opposite direction.
Oh, sure. So it's modular.
It is modular.
Yeah, okay.
And you can see there, we've got a break where it says figure 15.
Yeah, I see those.
We can take the entire back third of this unit off,
Right.
spin it around, and reattach it, and then it'll be figure 12, which is inlet sound
No
testing.
kidding.
Yes.
Fantastic. Yeah, a lot of thought process into the modular design of which I'm assuming, which is why we have this 10-ton crane up here.
Yes.
That's a lot of weight to lift manually.
We typically do this. We actually move this with fork trucks,
you
actually,
really?
because it's on wheels.
Oh, I got you.
Yeah, the whole fan carriage is on wheels. We can move the entire code tester out of the way if we
Yeah.
need to.
Wow.
Yeah. So the crane is primarily used for the equipment that you see around
Moving
us
them
to
through
move
the
that
actual
into
facility.
place. Yeah. Yeah.
Okay. Really, really cool.
And I don't know if you'd like, we can do a demonstration of the sound attenuators.
Ooh, yeah, that'd be really cool.
Okay,
Yeah.
great. So what I usually do is I tell the people that I'm giving the tour to that I'll ask them to step inside the chamber, close the door. You have handles on the inside, so you're
Right.
not going to be locked in. And then I will stand in front of the sound attenuators and speak to you in the same tone of voice and at the same level I am now, and you can see hear what the effect is of the sound attenuators. How much
And we ought to be able to
deadens
pick
the
that up well with both these microphones. We ought to be able to hear both. Oh yeah, I'll be able to hear you from the inside.
Yeah.
Okay, we ready?
Yeah,
Okay, let's
I'm
do
ready.
this.
So as I said when we were out here, I'm now talking to you in the same tone of voice and the same level of voice, maybe even a little louder than I was speaking to you out here. And you can see what the difference is in these sound attenuators and what effect they have and how they are so important to good indoor air quality, indoor acoustic quality.
That's very interesting because you're really only about 8 feet away from me, and I can just barely hear you. And machinery
can't hear
that I
you
heard
at all.
earlier, I can barely hear. And yeah, I can see your lips moving, and I can't even hear what's going on. I have to be very quiet to hear. So even though I have direct visual of you, those attenuators have completely silenced that audio sound.
I honestly can't hear a thing you're saying, so if you're asking me a question, I apologize. But there's a little
This is very
background noise
intriguing.
out here, so.
Okay. Yeah, thank you so much. It makes a lot of sense, though, when we're trying to keep a small amount of space and we're trying to dampen that noise coming through without restricting our airflow significantly.
Right.
We can actually just dampen that audio. Really cool. This is an audio engineer's intriguing place to work, I can only imagine. So you get to experiment with all these ways of manipulating sound. So Roger, besides being the research and development, you have a lot of customization that you have to do with these different components that are coming in here for testing. So can you tell us a little bit about the operation that you have over here?
Sure. So one of the features of this test lab that you haven't gotten to see yet are fantastic operators. They not only have to be able to run our data acquisition systems,
Right.
they also run our metal forming, sheet metal area, and our wood shop. When we're testing equipment, and we can see that a little bit later, we have to duct the equipment from the code tester to the unit under test and then into the reverb room.
Right.
The easiest way to do that is with plywood.
Sure.
Plywood's very easy to work with. It's very quick to build plywood ducts, and it reduces the amount of sound that breaks out of the duct.
Makes sense. You bet. The density of it works well for that.
Yeah, we want all of the sound that's coming from the unit to go into the reverb room.
Excellent.
We don't want to lose it out here in the lab, and that's what plywood allows us to use. And we also sometimes have to fabricate certain things out of sheet metal, so our operators have to be able to do all of those things, as well as piping work, which we'll see in a bit.
Right.
So they're very integral part of this lab.
Yeah, it's your own custom ductwork lab.
Indeed.
All right, very interesting.
Okay, so behind us is the pump and boiler skid that we use for the thermal testing of our data center units.
Sure.
So we modified this code tester about 3 or 4 years ago when we got into the data center market, so that we can do thermal testing on our equipment as well and prove to the customers that the capacity they're looking for is what we can provide them.
So you're putting the true physical load on the piece of equipment under test.
Indeed. What we do is we use this system to heat up the air going through the code tester, and then we pipe cold water into the data center unit to cool the air back down and measure the not only the temperature differential across the unit, but also the flow and the pressure drop through the system.
So you're looking for true capacity operating under a real load condition.
Exactly.
Nice. Okay, so so it's the backside of where we just came from.
Yes, indeed.
All right. So Roger, we went through all of our actual test equipment that we use for measuring our acoustics, measuring the airflow, looking at the dynamics of a new piece of equipment. This is actually the home of the equipment that we're going to be testing, correct?
Correct. This is our reverberation room. This is where we take the sound readings for the equipment that we're testing in order to qualify for AHRI 260.
Sure.
We use AHRI standard 220. This room is qualified per that standard. The room itself is 101,000 cubic feet, and it is made of 12 inches of poured concrete.
Sure.
The entire room is vibrationally isolated from the rest of the building.
Oh, really?
You can see this.
Yeah, see our separation.
At the floor, as well as structurally isolated. All of the wiring, the piping, everything is vibrationally isolated. We don't want any vibration or sound
contamination.
Yes, coming into the room, and we don't want to lose any of the vibration or sound that we want to measure in the room to the outside.
So that you can verify that any vibrations, any acoustics, any harmonics that you would get from that piece of equipment will be completely isolated in this concrete capsule.
Correct. Yep.
So Roger, what kind of frequencies are we measuring within this area?
Well, Clifton, the size of this room allows us to measure sound from 25 hertz on the low end up to 10,000 hertz on the high end.
Okay.
We typically only report sound down to about 63 hertz for our equipment, but we designed the room to be able to measure sound lower than that in the event that we would ever want to report sound at a lower frequency.
Okay.
But that frequency range is the typical frequency range of HVAC equipment, 63 hertz up to 8,000 hertz.
All right, Matt, so we're going to be heading into a facility I've not been to before. Can you tell me a little bit about it?
Yeah, so we call this JADEC, Johnson Controls Advanced Engineering and Development Center. We're heading into the chiller section of the area here, where all of our chiller test labs and component labs are here for our chiller products.
Okay. Whoa, look at that. So Matt, the first area I know that we're going to be stopping at is going to be the air-cooled side of your research and development here?
Yes, so on the outside of us here, we have 4 air-cooled test chambers.
Okay.
The center area here, it may look like it's kind of a manufacturing area, but it's
a staging area?
It's actually our staging area for all of our 4 test chambers on the outside.
Okay, so you'll actually be bringing these pieces of equipment into, different testing areas based on their capacity, their size?
Exactly. Each test chamber has a few different capabilities. Our first one here, they're all labeled beautifully. The first 2 blocks on the outside are 600-ton test blocks. This one has sound capabilities.
Okay.
The other one is just performance.
Sure.
Our back 2, which we'll get to, can only test up to 300 tons. On the right is our performance lab, and on the left is the lab that has low temp capabilities.
Oh, very cool.
Every lab can test up to around 131 degrees Fahrenheit.
Okay.
Our low temp lab can test down to around minus 20 degrees Fahrenheit.
So is that for our heat pump applications?
Yes.
Okay.
And most of our air-cooled chillers can run down to around minus 20, minus 10 Fahrenheit as well.
Really? Okay, fantastic. Yeah, that's going to be interesting to see, because one of the conversations we have is, the whole heat pump transformation within our industry. We're moving into a lot of high-performing heat pumps that are operating in these temperature range that we didn't typically think of a heat pump operating. And so now as we move into these rooftop units, air handling units that may have in the past operated on things like R22 and may had a balance point somewhere in the 30s or 40s degree Fahrenheit, well, that's not the case today. We have higher performing systems that are taking us into these negative Fahrenheit temperatures.
Yes, exactly.
Intriguing. All right, where are we going next?
Let's head through and look at some chillers.
Okay. All right, Matt, so we're actually just passing a pretty significant size piece of equipment. How many tonnage are we here?
This is one of our largest air-cooled screw chillers. It's around a 500-ton.
Wow.
We call it the YVFA. It has free cooling capabilities, screw compressor, and we have a few custom modifications on this one that the customer required.
Very, very cool. All right, Matt, so we're just moving past our large tonnage chiller, and we have a variety of different sizes here. So I imagine you have different equipment coming through at different times for testing throughout the year?
Yes, we do all the testing here is for research and development purposes only, so planning for the future and supporting the products that we have in the field already for the changes that are going on in the market.
One of the changes that we're starting to see is the development of our magnetic bearing compressors. And I'm slightly familiar with what we're doing over here. I know this is probably someone's test station, but I heard a term a while ago that I thought was pretty interesting. What is the name of this test station?
Yes, we call this the Whack-A-Mag. This,
like the whack-a-mole?
Yes, this station travels around to different areas. It was at our San Antonio water-cooled factory, and now it's here for different purposes.
So what we're actually doing is we're suspending our rotor inside of our compressor with our magnetic bearing assembly, but then we're looking for imbalances or shifts within that rotor. And so the reason that you actually have that hammer here is once someone rotates that like it was an operation, you can actually see the resonance from the impact of that hammer to be able to measure, monitor, and then of course the algorithms we're going to try to readjust to get that rotor back centered within the assembly. It's a very intriguing. Can I go hit it?
Yes.
Okay. All right. So when we look at a magnetic bearing technology, what we're doing is we're talking about removing those mechanical bearings. So we're removing friction as much as possible, and so we're using a magnetic center to maintain the rotation of our rotor. And so if you look on that chart, you're actually going to see the rotation of our rotor inside of our stator. And when we have shifts or changes in that rotor, it's actually going to show where the placement of that is. So if we had an imbalance of a rotor inside of that compressor due to a mechanical operation, the technology actually can shift that rotor. It can use the magnetic poles to recenter in very, very minimal increments to make sure that it keeps that rotor centered inside of that magnetic assembly. And so by doing that, it changes the way we can look at compressor technology. In the past, we've always had to match our refrigerants with the type of oil that's going to be operating in that compressor in that system. So when we start removing oil from our compressor, it opens up the opportunity to not only reduce friction, but to increase the variety of refrigerants that could be used in those applications. And so it takes a lot of engineering, a lot of technology to be able to produce a magnetic bearings that are typically only used in our chillers. But as we start looking forward, we'll start seeing magnetic bearing applications in a variety of applications. So the fact that engineers are having fun and they have their own wacka magnet game here, it's technology and engineering and fun that are meeting each other.
Pretty cool.
Yeah, it really is. You know, I spend a lot of our time in education trying to bring a little bit of humor into engineering and education, and that's a great example. I'm glad somebody's having fun with that.
Absolutely.
All right, Matt, so we've got a hot room and a cold room for doing testing. How low can the cold room go?
Our low temp room can go down to around minus 20 degrees Fahrenheit.
Okay, can we go take a look at it?
Yes, let's go in.
Okay. Be careful of the wet and icy potential floor. All right, so in this facility, especially when we're testing heat pumps, we can actually bring these in, put them in actual negative temperature conditions to where we can simulate the operating atmosphere that this unit would be performing in.
Exactly. All of our air-cooled chillers have to work even when it's cold out still.
Yeah.
And our heat pumps especially have to produce hot water when it's very cold out. So this test lab is able to run them through all the different conditions and parameters that they have to meet.
Sure. That way we can simulate what they would normally see out in the real work environment down to minus 20 degrees Fahrenheit. Very cool. Now, if we were testing this same style of unit for its high temperature, we would take it over to the hot lab. How high does it go over there?
We go up to around 131 degrees Fahrenheit.
Okay, pretty realistic.
Each air-cooled test chamber can go up that high.
Yeah.
But only the low temp room can go below 55 degrees Fahrenheit.
Oh, okay, gotcha.
So the normal operating range is 55 to 131 for every test chamber besides this one.
Okay, very cool. Appreciate you showing us. So Matt, we're leaving the air-cooled staging and now we're going to be heading over to the water-cooled staging area?
Yes, well, right behind us is actually our water-cooled staging area. Everything behind us here, starting here, is our water-cooled test blocks.
Oh, okay.
So just like our air-cooled staging area, everything's done on the inside to get them ready for the blocks. Our water-cooled staging area is here, and then we bring them into the actual test blocks.
Okay. So this is our water-cooled test block area?
Yes, we have 10 stations here, 5 test blocks. In order to reduce time, we have one on each side of the test stations. We can have 2 units set up at once. Only one can be tested, but that way we can, reduce test time that's needed.
So you're actually putting these on a full load then?
Yes. So we can test over here. We test up to around 2,000 tons and all the way down to around 200 tons.
Oh, no kidding.
And
all
lower,
right.
but nominal tonnage.
Absolutely. So once we've designed a system, we can actually bring it in here, put it under full load, and get its test conditions out there in the real world scenarios. So I assume we're sending these out to cooling towers outside?
Yes.
Okay, very interesting. So any highlights? What's been the biggest changes that we've seen in the water-cooled arena in the last few years?
The refrigerant change was a large one. Everything had to be redesigned for the new refrigerants that we have to use. So any product that used 134A had to change to 513A.
Okay.
Or we also have the zero GWP refrigerant 1234ZE available for some of our products.
Sure, I've seen that become popular very much in Europe, and so we're starting to see a lot more of that here. So as our chiller technicians start transitioning into next generation equipment, we're going to be transitioning into a lot of different refrigerants as well. So it's good to know like where we're headed to with that. Okay, what's next?
Okay, let's continue down the water-cooled area.
All right. Well, Matt, on the other side of the building where we just came from, that was really the air side where we were bringing in pieces of equipment, putting them to test chambers to measure airflow, pressure drops. We're looking for harmonics. We're looking for audio signatures, making sure that things are in a certain audio parameter. It's a little bit different when we move over to the water side, but we still have a lot of performance that we need to measure. So what are we actually testing for when we're in the water side test stations?
So here we're testing chillers at different operating conditions.
Yeah.
So water cooled, all the different water temperatures that a customer requires. So comfort cooling, 44 degree leaving. We're going to run that at different flows.
Sure.
we're going to get peak performance at full load and then try to find the best efficiencies at all the different part load points as well.
And some of the new pieces of equipment, we're actually doing turn down ratios where we can reduce the capacity of those so that we have flexible capacity range. So we're actually going to be looking at those ranges as well?
Yes, exactly. A chiller only operates at its full load point for a small portion of the year.
Right.
So the customer really cares about the efficiency for the rest of the year.
Part load conditions,
Exactly.
which is a big thing, especially when we're talking about like heat pumps and we're in the heating cycles. What are those partial load performance ratings? Because unfortunately in our industry, we've been spending a lot of time talking about like maximum performance at full load capacity. And you're right, most equipment doesn't run at full load capacity. It's running at variations of that. Understanding the capability, the capacity, and the performance at partial loads is really important when you're designing systems of these capacities.
Yep. Everything here is to simulate what real world conditions are, and all the work here has to happen before all the different software tools we have available for our customers and salesmen to actually go in and select our units and rate our units at all those different conditions. Everything in this building has to happen before anything is released out to that software.
Makes sense. Fantastic. You use all of your own chillers to actually move the heat out of this test area, especially on this water side, but you have a lot of pump power to do that, right?
Yes.
So can you tell me about this aisle of pumps that we have here?
Yes, right here we call this our pump room.
Yeah.
All the different pumps and condenser and evaporator loops are fed from these pumps here.
Sure.
And on the outside of the test lab, we have a bank of 10 of our 500-ton air-cooled screw chillers, the YVAA, that supports the entire test lab.
Right, so this is all circulation for our test area.
Yes.
Man, that's a lot of movement of water.
Yes.
Glycol and anything we're chilling here.
Yep.
Fantastic. Matt, being in a research and development lab, there are areas that we're not going to be able to show to the public, like our VSD, like our electronics and controls and panels design. There's a lot of proprietary information that we're not really going to be focusing on, but we can show some of the results of the engineering that goes into that.
Yes,
Is that correct?
exactly. Up there's our VSD and power electronics test lab.
Yeah.
We design and create our own VSDs for the majority of our products.
Sure.
We cannot go in there right now, but in here in our warehouse, we do have some VSDs that we can show.
All right, let's go do that. That'd be great. Come along. So as we are building our chillers and we need our controls, you have a variety of different custom-made controls, I'm sure, for each chiller and different application. Probably a lot of that comes from the engineering specifications that come from the contractors as well.
Exactly. Different size VSDs are required for all the different tonnage ranges that we have and voltage ranges that we have here available. Like I said, we do build and manufacture and design our own chillers. And yeah, here kept in the warehouse, we have it available for the test lab for any different changes or things that are needed for the actual unit testing.
Okay, I appreciate you showing us this.
Absolutely.
Now, Matt, when we were in the air side, we're doing a lot of research on like acoustic resonance and reflection. So we were encouraging the sound to reflect off from the surfaces in that room. It's a little bit different over here on the water side test though, isn't it?
Right. All of our chiller sound chambers are hemi-anechoic rooms, so they're designed to deafen and absorb sound so that we can accurately test the equipment in that chamber only.
Okay. So can we give it a try?
Yeah,
all right,
let's walk in.
Yeah, we're out here just in an open environment where we have machinery, we have people moving around, and as we move into this atmosphere, we're now moving into a sound isolated environment.
Yes.
Even the floor below us is isolated from vibrations?
Yes, each sound room is on its own foundation, separate from the rest of the test lab to separate any outside noise and vibrations, yes.
And so the room is completely acoustically insulated, walls, ceiling, and even though we have that door open, it's like we're in our own little space here. So I can imagine once those doors are closed, this is a completely sound isolated environment.
Yes.
Very intriguing. So we can find the most minuscule sounds and vibrations coming from a piece of equipment completely isolated from everything else.
Yes, customers care about the noise of their equipment that's either inside their building in a mechanical room or for outside units sitting outside of the building.
That's a lot of dedication to quality.
Absolutely.
All right. Cooper, how's it going?
Good.
We're spending a lot of time here at this facility, and I'm so glad we had a chance to kind of talk about like what you do here and show different aspects of HVAC. We're in this incredible research and development facility And a lot of times people, when they look at HVAC, all they see is like the residential furnace installer, and they don't see all the opportunities that we have. So what do you do here in this facility?
So I am a test lab operator. I set the chillers up to run, to go to certain conditions, and then we reroute piping and remove compressors if they break, put new compressors in if we want to test new compressors.
Right.
Do fan swaps, a little bit of everything.
All in a, 70-degree environment,
Exactly.
nice and
Best
clean.
part.
Yeah, exactly. So, a lot of our students that come out of programs and they may be introduced into the residential HVAC side and they go, man, I don't know if I want to do this, but I really like working on this stuff. And here you get a chance to tear apart equipment that's hundreds of thousands of dollars for the fun of it, right? That's a pretty good gig.
Yeah, I'd say.
And I'd like to spotlight that and to show people that there's so many different opportunities within our industry, and we can't be confined to just a box as this one stereotypical job. That there are so many different roles in our industry. There's probably hundreds of different jobs within this one building that are all HVAC.
Yep.
Awesome, thank you.
Yep, no problem.
All right, welcome everyone to the Johnson Controls JADEC Technical Training Department. So we spent a lot of time learning about the new technologies and innovations, the engineering that goes behind these incredible pieces of machinery. Well, then we're actually going to transition over to the classroom where we're going to learn about the fundamentals of chillers. We're going to go into the design, and then we're also going to go next door into a hands-on lab that we'll be doing equipment teardowns, looking at the pieces of equipment that comes through in the classroom that we actually get a breakdown that is the exact piece of equipment out in the industry. So a teardown, an inspection, and a rebuild of chillers. Now, if we walk through this facility, you're going to find a variety of cutaways talking about different generations of compressors, right? We'll look at magnetic bearing compressors, which is one of our newest products. This is actually a live functional demo to look at the operation of a magnetic bearing chiller. We're actually going to have the opportunity to look on the inside of some of the newest generation of screw chillers. We've seen some of them that were being tested out in the laboratory. We'll actually get to take a look at how they're constructed inside. We'll take a look at some of their VSD controls to be able to see how we actually implement the controls for our compressors. And we even have the opportunity to take a look at some of the original generations, the original prototype of our screw compressors. I've actually had the opportunity to work on these in the field, to be able to do classes on industrial chiller and show the principles of how they work. I've never had the opportunity to see one on the inside, and it's a really neat experience. I encourage you to join the training here at JADEC to dive deeper into chillers and the compressors that run them. Education is one of the most important parts of any product. When we look at technology and innovation, it's hard to comprehend a product, at least as a technician. It's hard to comprehend a product until you actually have the opportunity to tear it apart, to put it in your hands, to understand what it is. So there's two components to a proper educational program, at least in my perspective. You have your theory, you have your fundamental aspects, which is required to understand the technology of it. We need to understand how something is manufactured. I need to see my print so that I can look at how it's built. I want to see my wiring diagram so that I can look at how things are constructed and wired. So I've got my troubleshooting, my fundamentals. But it gets a little bit deeper than that. Paul, how are you doing today?
Doing good, sir.
I have such a respect for your classroom. We haven't even been here very long, and I've already recognized what you're doing. And to me, it's the heart of education. As a service technician, I have to be able to understand how something works, but then go tear it apart so that I can get a glimpse into how it was designed to operate. It's almost like reverse engineering, I think.
Yeah, that's a lot of how I've learned in the field.
Yeah.
Is taking something apart, figuring out how it works, and then fixing it.
Exactly. A lot of classrooms that we go into, we'll have our fundamentals, which to me is the most important thing. I didn't learn on all the fundamentals. I learned because things were broken and I got a chance to try to fix it. And then I became more successful at fixing and more successful at fixing. It wasn't until later in my career that the fundamentals made me a better technician. And so I look at our classrooms and the design of the classroom, and I completely have a passion and an appreciation for when you do things in the manner that you do, where you bring them into the classroom and we're learning the fundamentals, we're learning how things should operate, we're going to go through some education, we're going to get some component hands-on pieces, and then once we get comfortable here, then we're actually going to go work on it.
Yes.
Now that's a different aspect.
So that's part of it sitting behind us here. These units back here, they are all operational.
Right.
And then I have the bits and pieces in here, and then we have the lab next door.
Okay, so we're going to go take a look at the lab here in a little bit to show you the experience that you get when you come to JADEC. It's not just about going through all of the engineering, the innovations, the technology that is being used to make products better. It's about learning from those products, understanding how they actually work, and then becoming a technician to work on those components. So we're going to move from this lab, and we're going to go over to the hands-on, and we're going to look at some big pieces of equipment. I'm excited. Okay, let's go do it. Okay, so in our previous lab and classroom, we learned the principles, we learned the fundamentals, we get a look at some parts and components, but when we move over into this area, we really get into the equipment itself, and we start, getting to examine how things are made, when things go wrong, what does that look like? Can you tell me a little bit about this facility?
In here, this is our teardown lab. We've got the 3 different types of compressors.
Yep.
They're YK compressors. We do tear them down completely.
Oh, really?
So
in class?
In class.
Okay.
They come completely apart. We will take PRVs out as well. The VGDs that are in these, all 3 of these have VGDs in them. That's a variable geometry. So they're the most complicated compressor that we have on the YK line.
Okay. So we get to learn how the compressors operate. We get to see their construction. Then we get to come out here and tear them apart.
Actually tear them apart.
Oh, boy. All right.
Some of the things they do is, as they're taking it apart, they will take measurements. So we'll do thrust and radial runouts.
Yeah.
Then when they put it back together, it should be at least as good as it was, if not better.
When it was new. Right. And this is not just a class for technicians that you were telling me about. That you have, or employees will even come into these classes.
Employees and customer technicians. It's not just limited to Johnson Controls.
Okay.
We will teach anybody how to repair, tear down our compressors, at least on the YK.
Yeah.
They will get current M manuals, which are not easy to come by.
Sure, exactly. Yeah,
that's
intriguing.
They get current proprietary information.
Okay. Hey, Paul, so when we're in these teardown stations, what are we actually going to be doing and looking for on these compressors?
They will be doing a bunch of measurements on them, doing run-out thrust measurements.
For the impeller.
For the impeller.
Yeah.
And for the low-speed shaft. They will actually take this apart. So the part your hand was just on, this entire part.
The whole bell's going to come out?
This whole bell will come out and go on this jig.
Okay.
And then it will be disassembled all the way down to the frame.
Oh, wow. Okay.
They'll go through each individual piece, and then they'll put it all back together.
Sure.
Inside the scroll assembly, which would stay up in here, we have the VGD and the PRV. They would also pull that out as well.
Okay. Inspect that.
And inspect that, and then put it back together.
So by the time they get done with a fundamental understanding of how they're designed, they're going to tear them apart, inspect, correct, put back together, and so basically the same as doing a full service inspection and rebuild in the field.
Yes.
Absolutely.
It would be exactly like they would do it in the field, except that we have nicer jigs in here, so it does go a little faster.
A little easier to do in here.
It's a little easier to do in here. It's about a 12-hour process.
Yeah.
So taking them apart completely, including the PRV and VGD, getting it all back together.
Sure. How long are the classes total?
The compressor teardown class lasts a week. The customer one also has a 1 teardown. Each group gets to do 1 teardown.
Yeah.
And then we have the OptiView section where they're going to be taught how to take care of the OptiView control
Dive
system.
into the control side.
And then we do a big lecture, a lot of lecture on the actual chiller, the YK chiller itself, and how to service it.
Fantastic. Okay.
And then, of course, we start out with theory, and I tie everything off on the pressure enthalpy chart. It gets drawn up at the beginning and just stays there.
Yeah, I noticed a chart over there, so you're actually implementing it into the classroom. Yeah, so we're looking at performance.
All right, so we have an OptiView panel right here. There is a purge unit behind it that goes on the YZ compressor. this OptiView will operate that purge unit there.
Okay.
Technicians are able to set it up, and we've got 3 different modes that it can be set up in.
Okay.
So they're able to actually physically do that with the OptiView and see how it operates slightly different each time.
Get comfortable with the controller and with the piece of equipment
And
itself.
with the piece of equipment.
Yeah, very cool. Good piece to be able to get comfortable with. I always like to have those conversations with instructors that come to us that are looking for training on products. You know, what instructor wouldn't want to come do a hands-on class on a teardown of a chiller compressor, right?
I learned a lot the first time I did one in here.
Exactly. And so that's why we encourage this. We want people to understand that the resources are out there, and it's not always necessarily proprietary, that there are opportunities to learn about products and equipment and technologies in the industry. All you have to do is reach out and have those communications. Awesome. Thank you.
Thank you.
Well, that's a wrap up of our exclusive tour of the Johnson Controls Advanced Development Engineering Center in New Freedom, Pennsylvania. A huge thank you to the entire Johnson Controls team for opening their doors and giving us an inside look at this incredible work happening behind the scenes. And of course, a special thanks to our amazing team at Godfrey Marketing for providing the recording, the production, and support to make this tour possible. Thank you for joining us. And if you enjoyed this behind the scenes look, be sure to like, subscribe, and stay tuned for more exclusive content from inside the HVACR industry. And we'll see you on the next ESCO Roadshow. All right, so what do you all think? And there's still quite a few people hanging in with us. I know it's a lot to watch, and there'll be bits and pieces of that getting released as we move forward, and so many other types of content, right? That's chillers. I know a lot of our educators don't spend a lot of time on chillers, but if you're interested in learning more, this is the resource, and it'll give you an idea of what it looks like behind the scenes. All of our equipment manufacturers are showing us that they have technical training available for educators, as well as our contractors and technicians. And so that's really what we want to do, is we want to spotlight these types of programs and what is offered and what does it look like behind the scenes. We've got a couple that we've done where we're actually in the manufacturing side. The one we're going to be doing with Hudson, where we're actually following that recovery cylinder from the time it's manufactured to the time that you utilize it, bring it out to the distributor, and distributor transfers it over to the reclamation facility. The refrigerant gets reclaimed and then gets repackaged and tested. Those are all things that we're going to be showing, but we need to know what you are wanting out of this and what types of facilities you want to see the most. So we'll try to blend things up. We'll continue doing our standard technical training classes, but I'd like to blend in some of this in the background, driven by what you want. Yeah, it is, Paul. It's a very interesting perspective, and I wasn't sure how it would be received because it's not exactly the technical that we do, but it really is education. It's opportunities for us to see things that we might not normally see, and hopefully we can show our students and we can show the students' parents the different types of work that you can do in this industry that will provide a very significant career lifestyle. It's been good to all of us, and we continue to give back. Well, I think we're going to wrap it up for a day. I'm grateful that you all hung in here. Let us know the things that you want to cover. We're booking out like a month and a half ahead right now. We got a lot of things coming up, but it's got to be the things that you want to see. So let us know, and we'll keep having these discussions of what's next in our pipeline. So everyone, have a fantastic and safe holiday weekend, and we will see you all again next week on Did You Know? The ESCO HVAC Show. Bye, everybody.